All right, so here's the problem, and it says the radius of the nucleus of a carbon-12 isotope is approximately 2.7 femtometers, and the radius of the atom is approximately 70 picometers. Okay, I really should have a decimal place right there so we can have two decimal places in our answer, but it wouldn't really matter in the long run because if you only had one decimal place, you get the same answer basically. All right. So the question is, if the nucleus of this atom were the size of a baseball, which has a radius of 7.6 centimeters, how big would the radius of the carbon-12 atom be? There are lots and lots and lots of ways to solve this problem. In order to compare the two sizes of the nucleus and the atom, I've got to have common units. Okay? Now that means I can do one of three things basically. I can do a lot of things, but one of three simpler things is to change femtometers into picometers to compare them, change picometers into femtometers to compare them, or change both of them into meters and compare them. Because you can't compare sizes unless you have the same units of measurement. Okay? Any one of those three things works. So the way you choose to solve it depends on the way you want to solve it, as long as you know where you're going. And where you're going is trying to compare the two sizes. Right. That's the first thing. First thing you do is figure out which one's bigger, and then you want to have a factor for converting your baseball size thing to the size of the map. And we'll get to that. So I'll tell you what. Let's do. Let's convert the nucleus. It says the radius of the nucleus of the carbon-12 isotope is 2.7 femtometers. Let's convert that into picometers, which is what the radius of the atom is measured in, so that we can compare the two. That makes sense? All right. So 2.7 femtometers. All right. Now, we are looking at two different radii. We're looking at the radius of the atom. We're looking at the radius of the nucleus. We're also looking at the radius when we change the nucleus size to 7.6 centimeters and see what the size of the atom is going to be. Okay? So there's a lot of different things to keep up with here. And so labeling things to know what it is your numbers mean is going to be critical. This is where dimensional analysis is so important. Okay? If you were watching the video that was on before class started, that's what he was talking about. Basically dimensional analysis, among other things, units of measurement. All right. So femtometers measures what? That's what's important here. What is femtometers measuring? Huh? The radius of, can I say RAD for radius? Is that okay? Radius of what? The nucleus of a carbon-12 atom. So C12 nucleus. Okay, so I keep them straight. All right, so I'll make that my starting amount. This way I keep up with exactly what it is I'm changing the measurement of. Got it? I'm going to put that over 1. Because all of our starting amounts always go over 1, don't they? All right, good. Now, using what's right here, there's no way to get directly from femtometers to picometers. I don't have an equality that gets me directly from one to the other. You could probably figure one out if you're really took enough time and thought about it. But what we're going to do here is we're going to convert femtometers to meters, and then once we have it in meters, we're going to convert meters into picometers, so we can compare that against the size of the atom itself. Got that? All right. So if I'm going to convert, I need a conversion unit. Conversion units come from what? Unit 1. What do conversion units come from? If you want to, equality statements. Conversion units come from equality statements. If you don't have that written down in your notes somewhere, if you don't remember it, and apparently nobody did, nobody spoke up, okay, you should be writing it down because you need to remember that. Conversion units come from equality statements. Okay? Equality statements. Now look, something that's really, really important in terms of your preparing for college, and this is a college prep class, is that in college, the professor's not going to stop and say, okay, you should write this down. The professor isn't going to stop and repeat things 3 times like I do. If there's something I say that you don't already know, you need to know. that you need to write it down. That makes sense? All right. Now some things are important, some things aren't, and so you gotta sort it out some. But the important stuff, if you don't know it and it seems essential to doing what you got to do, write it down. Because the way you remember things is hear, see, write. Okay? You emphasize the memory when you do it in writing. Does that make sense? That's kinetic. That's part of kinetic learning. Okay? If you think you're a kinetic learner, you raise your hand now. You need to write stuff down. Okay? If you're a visual learner, write it down because you're seeing yourself write it. Okay? And even if you think you're just an auditory learner, this is emphasizing that stuff and helping you to remember it. Okay? The fact is that everybody, regardless of what learning style you think you have, everybody learns in all three ways. Okay? You might prefer one over the other, but everybody learns in all three ways. Okay. So, which equality statement am I going to use from this problem, or this list of equalities I have down here? 10 to the 15 femtometers equals 1 meter, or I can use this one over here. Doesn't matter which one I use. What do I want to put on the bottom then? Yeah, femtometers. Yeah. How many femtometers then? 10 to the 15 femtometers can go on the bottom. Not over, yeah. 1 meter goes on the top. Okay, good. All right, now if I cancel the units, I now have meters. Now I can change meters into what I'm trying to get to picometers. So what do I put in this conversion unit? Okay, so this needs to go on top. The 1 meter needs to go on the bottom because I've got meters on the top now. So 1 meter goes on the bottom, and I'm trying to get to picometers, so I'm going to put 10 to the 12th on top. And that's picometers. Now I'm ready to find an answer to this. .7 times 10 to the 12th. Okay, and I get that answer. Then I'm going to divide by this answer, divided by 10 to the 15th. Whoops, I didn't do the right thing there. 10 to the 15th. So let's see, maybe you see it. There we go. Maybe. There we go. All right, so I'm taking 2.7 and multiplying by 10 to the 12th. Then I'm going to take the answer I got. This was the answer I got over here. And I'm going to divide that answer by 10 to the 15th down here. Let's see. Okay. You get the same thing? Oh, yeah, I got that. Okay. Equals 0.0027. So you got to learn to talk your calculator's language. Now your answer could have also been in 2.7 times 10 to the negative 3. Okay? Let's cancel out all our units. And let's figure out how many units and what description we're going to give to it. The units we have left are picometers. And the description this applies to is the radius of the carbon-12 nucleus. Alright, so that's the radius of the carbon-12 nucleus. We want to compare that against what the problem says is the radius of the atom itself. And what was that? 70 picometers. Alright? So, which one's bigger? 70 picometers is bigger than 0.027 picometers. Okay? So let's figure out how much you have to multiply by to go from one to the other. Now, if I want to figure out how much to multiply by, I find it by doing the opposite of multiplication, which is division. So I'm going to take 70 picometers. Yep. 70 picometers. Now, what is this 70 picometers measuring? The radius of the atom of the C12, not the nucleus, but this is the atom. You got to keep them separate. All right, and I'm going to divide by the radius of the nucleus, so I can find out by how much the atom is bigger than the nucleus. So 0.0027 picometers radius for the C12 nucleus.
Wait, why did you divide this?
So I can find out by how much this is bigger than that. That makes sense? That's what we're trying to find out first, is how much the atom is bigger than the nucleus, so we can take the baseball size and make the atom bigger than that. Okay? We will. That's the next step. Just bear with me here. Okay. Let's do this math. Okay. Can we simplify it all? Well, picometers is the same, isn't it? Now, the radius of the carbon-12 nucleus and the radius of the carbon-12 atom, those are different things. Those kind of all belong together, so we're not going to cancel those. But we are going to cancel picometers. And so I'm going to take that 70 and a decimal place, and I'm going to divide by the answer I got in the previous problem.
I got a long number.
Trying to get it to light so you can see this better. Okay? I'm going to divide by that number right there. So let's see, control there, give me the answer. I'm dividing by the previous answer. Okay? And I'm going to hit enter. And I get a really long answer. You're right.
Yeah, he's done 7.
Oh, let's do that again then. 7D, I thought I did, divided by 0.0027. Enter. Well, no, it's 10 times bigger. It looks like the same thing if you're not careful. That's right. All right, so our number then, 25925, decimal place, 9259259. Okay, now, units are radius, C12 atom. Oh, they're units. Units cancel. This is species. Compared to the radius of the C12 nucleus. Okay? Well, how many significant digits do I need? Just the 2 and the 5. So I got to round off. But if I'm rounding off numbers in the ones place, how do I have to write the answer? Yeah. So I'm getting rid of all these 3 numbers here because I only need the first 2. And if I'm getting rid of any number in the ones place, my answer needs to be written in scientific notation. So I'm going to underline everything past the 5 here, or this 5 anyway. All that's going to be rounded off.
Wait, why anything past that now?
Because I've got only 2 digits in the 70.
Oh, word.
And so since this is multiplication, well, actually, there's only 2 significant digits here either. Both these numbers right here have only 2 significant digits. So my answer needs to have 2 significant digits. And so I'll move my decimal place 1, 2, 3, 4 places. Because you always have to have your decimal place between the first and second significant digit. The first significant digit is always the first non-zero digit to the right as you go from left to right. So that's 2.5 times 10 to the 4th, because I moved it 1, 2, 3, 4, 4th power. And this is radius of the carbon-12 atom compared to the radius of the carbon-12 nucleus. All right? Why 3.6? Oh, right. Oh, man. Yeah. What I do wrong?
Oh man.
I did round, but I rounded incorrectly. Why? Huh? The 9 makes the 5 round up, so it should be 2.6. Okay? There you go. Good look, Fred. All right. Now, we know how much bigger then the atom is than the nucleus. Here it is. Got that? All right. So we want our atom to have a nucleus that's how big? In our new way of comparing it, how big do we want the nucleus to be? How big do we want our nucleus to be? 7.6 centimeters. So this is 7.6 centimeters. And what is this the size of?
The breadcrumbs.
Yes, but we're going to make it the size of our nucleus, aren't we? So this is the new size of our carbon-12 nucleus. That's the new size, right? That's what we're trying to get to. If this is the size of the carbon-12 nucleus, how big is the atom? Well, we just take this size right here and multiply by that factor. But let's see how that works out with dimensional analysis, because it's really cool. Put this over 1. And what can I put on the bottom that's going to match something? Well, I don't have any centimeters in this thing, but I do have, yeah, the C12 radius of the C12 nucleus is on the bottom here and on the top here, right? So if I arrange it like this, 2.6 times 10 to the 4th power radius of the carbon-12 atom over the radius of the C12 nucleus, what cancels? That all cancels right there, doesn't it? So when we get done with this, we'll know the radius of the C12 atom if our nucleus is 7.6 centimeters, like a baseball. That make sense? All right. So 7.6 times 2.6 times 10 to the 4th power, correct? I got 197,600. Now, if you're not doing this on your calculator, you're not helping yourself very much, because if your calculator doesn't work exactly like mine, you need to learn to speak its language. You need to learn to talk like your calculator. Okay? So, if you get a different answer, now's the time to figure out why and get that corrected, not when you're taking the test. Well, that's the point. That's the reason for getting it out and using it. Get out and use it now, and you can figure out how to talk the same language. Is anybody working on the calculator? Raise your hand. Let me know so I can stop, pause, and wait on you. Okay. So if you do all this math with me, we can figure out what difficulties you're having with your calculator, talking to your calculator, talking its language now, and then when you get on the test, you're more likely going to have the correct answers and not some bogus answer. Different calculators require different syntax. On this? What you have questions about this? What's your question?
That 2.5 yeah, how did you get all that times?
10 to the 4th?
No, I'm talking about the top there.
That right there?
No, the top. The top, there you go. How did you get all that right there?
That's 2.7, not 2.5.
I just put 2.5.
Okay. We took this number right here, 2.7. We multiplied it by 10 to the 12th power. We hit enter on the calculator and got an answer for that operation.
Now, I know how you did that.
Oh.
I'm talking about how you did that
No, I don't know what you mean.
like get the division times division. Like on the chart. How do you know which one to use?
Oh, okay. So with dimensional analysis, you're trying to set up your conversion units, so you either have the same species on the bottom as you started with, or the same units of measurement. In this case, it's the units of measurement that are the same. So that you can, and then the top of the fraction is the other side of your quality statement from here. Here's an equality statement that says that there are 10 to the 15th femtometers in a meter. These conversion units come from equality statements, right?
Why didn't you use the 1 centimeter?
I could have, sure. I could have put 1 femtometer up here and 10 to the negative 50 meters up here. That would have worked too.
Oh, okay. I was just
Okay. They both work. All right. Is anybody getting a different answer on their calculator?
Next.
All right then. How many significant digits do we need? 2 significant digits. Underline everything else.
You got it round.
Move our decimal place 1, 2, 3, 4, 5 places. We need to write down what units of measurement. This is centimeters. We need to write down our species, radius of the carbon-12 atom. So neatness counts. You've got to keep up with all this stuff, okay? Now we're ready to round off. Okay, now if we're going to move our decimal place here, then I'm getting rid of the 7. That 7 makes the 9 round up to a 10, which carries a 1 over to here. So our rounded off answer is 2.0 times 10 to the 1, 2, 3, 4, 5, fifth power centimeters radius of the carbon-12 atom. Now, so the question says, or what it tells you at the bottom is, draw this diameter on the map where Dorman High, labeled A here, is at the center. So that's where our baseball-sized nucleus is going to be, right there where A is. Okay? But this map has measurements in meters, 500 meters over here. That's the only measurement we have for distance. 500 meters is how many kilometers? Or kilometers? It's half a kilometer. So this distance down here in the bottom corner, this is 0.5 kilometers. Okay? That's how we're going to figure out how big our radius is going to be. But we've got to convert this to kilometers to do it. So that becomes a new starting amount. 2.0 times 10 to the 5th centimeters radius for a carbon-12 atom. Put that over 1. Now, how do I convert centimeters into kilometers? And it's all right here. Okay, centimeters into meters. And then meters into kilometers, okay? So what do I put on the bottom here?
Centimeters.
How many?
1.
Okay, you want to use 1 and 10 to the negative 2?
Yeah.
Okay, on the other side over here, it's a little bit simpler. Is that okay if I use this side
Oh,
over
yeah.
here? I like that side better, just because and it's just easier to write. 100 centimeters to 1 meter, okay? And that's going to allow us to cancel centimeters, and we have meters. We want it in kilometers, so what's the relationship between meters and kilometers? You're 1 over 1,000 is fine. Yeah, 10 to the 3rd is 1,000.
10 to the 3rd kilometers.
10 to the 3rd is the same thing as 1,000. Okay. I could
Put 1 minute on the bottom.
1 meter on the bottom.
And 10 to the
10 to the 3rd. Can I use 1,000 instead, or you want 10 to the 3rd?
whatever you want to.
Well, it doesn't matter. You can actually you can do it either way. There's lots of ways to solve the problem.
I don't have to put like that 10 to the 3rd and 10 to the 3rd.
You can. Or you can either put 10 to the 3rd, or if you know 10 to the 3rd is 1,000, you can put 1,000.
Yeah, I see that in mine. I thought this was a 2-step equation.
There's 2 steps. One conversion and then another conversion.
Well, that's 3 is about 5.
No, the step, if you just write this, that's not a step. That's the starting place. The step is when you convert, that's another step. This is a 2-step conversion. That's what I mean when I say that anyway. Okay? Scoot it down like this. All right. Okay, that's fine if you have 1 kilometer on the top and, let's see,
I got 2 million.
you'll get the same answer.
Is that wrong?
Not necessarily, yeah, that is wrong. You must do your math wrong. Oh, this right here?
I got the answer is 2 million.
I don't think so. I'm wrong. About what? Oh, I got this wrong, don't I? It's 1 kilometer on the top and 1,000 meters on the bottom, isn't it? Okay, you're right. You're right. When you're right, you're right.
Oh, see, you messed me
I'm sorry.
Instead of that, use your calculator.
Yeah, you got a dollar? Wait, where's yours? You have one?
I have my phone.
Oh. Yeah, you can use mine, but you need to get a calculator so you can practice this stuff, be able to do stuff like this on the test, okay? If you had a calculator, I'd want to take some time with your calculator and help you show how to use it.
Wait. So when it says to the fifth, do you go to the right with the decimal place or to the left?
Correct. If positive numbers means you got to move the decimal from here over if you want to do that. If you're rounding off, you move it to the this way.
So if it's a negative, you go to the left, positive?
Yeah, you can think about it that way, sure. All right, so now pay attention here. This is really important, guys. We have two different math operations here. We have 10 to the power of 5, and that number times 2.0. So in order to keep your order of operations separate, you might need to, you said, depends on what kind of calculator you're using, you might need to put this in parentheses. I'm going to show you what I'm going to do here. I'm going to put this in parentheses. I'm going to say 2.0 times 10 to the 5th power. That you may need to put that in parentheses to keep that separate from the next operation. Then we're going to divide by 100. And I'm going to hit enter before dividing by the 1,000. All right, because they're separate operations. If you try to put this in, divide by this, it may give you a wrong answer.
I multiplied those numbers and then I divided them.
Well, if you're,
I typed that in first.
that's fine. Just have to keep your operations right. How many kilometers did you get? 2. 2.0 though.
Mine just says 2.
Yes, your calculator says 2, but you got to be smarter than your calculator. How many significant digits do you have? How many significant digits? And the only number that matters here. These are absolutes here. We don't worry about those. This is the only one that matters, so our final answer needs to have the same number of digits as that. 2 kilometers radius of the carbon-12 atom. There's your distance we need for our radius. All right. So, I'm going to make a mark here and find half a kilometer. If that's half a kilometer, how much is 2 of them? That's a whole kilometer. And if I do another one, that's 1.5 kilometers. And if I do another one, I've got how many kilometers? 2 kilometers. That's our radius. All right. So I'm going to put a dot here. I'm going to put a dot here. I'm going to put a dot here. Dot here. Because this is where my radius is coming to. If I have a compass, I could use a compass, but I don't have one, so I'm doing this. Okay, so that's my radius needs to go out to those dots. Something like that. So if you put a baseball on the floor in the lobby of Dorman High School, and that were a nucleus for a carbon-12 atom, this would be how big the atom would be. And there's only how many electrons in a carbon atom? 6 is right. There's 6 protons, 6 electrons. That's a lot of space for 6 electrons. That's like 6 specks of dust in all that space. Okay? All right. So an atom is mostly what?
Air. Space.
Space. An atom is mostly space. there's a nucleus at the center, like the size of a baseball, if it's this big, but mostly it's space. What? What now?
I said what holds the nucleus there?
Oh, wherever it goes, the electrons go. So there's nothing holding it there. It can float through space.
Oh, so the nucleus don't just stay in the middle of floating around?
Oh no. Wherever the nucleus is, the cloud stays with it. If the nucleus moves this way, the cloud moves with it.
Oh.
Okay? All right. So there's several things that you're learning from this activity. I hope you're learning. And if you're talking about other things instead of learning this, then you're not learning as effectively as you need to. If you're texting on your phone, you're not learning the way you should be. All right. One thing is how to do multiple step conversions. Okay? That's really important. Number 2, practicing dimensional analysis. That's really, really important. Keeping up with the units of measurement, keeping up with the things that what those units of measurement are measuring, what that number in units of measurement is measuring. Okay? Figuring out what steps you need to follow to get a problem. That problem-solving process is very important. But it's also very important that you understand how vast the electron cloud is compared to the nucleus itself. All right? It's very important you understand that atoms are mostly empty space. Okay? Now, atoms make up everything that's physical. All right? So all those molecules, those really huge molecules that make up your brain, they're all made of atoms. Yep. So if you've got a bunch of atoms that are linked together to make molecules, and all those molecules are linked together to make your brain, then if somebody calls you empty-headed, they're almost right, aren't they? Because it's mostly space up there, isn't it? Okay. What? What'd you say? They're not quite right, but they're close. All right. Let's review real quick what we covered so far in periodic table stuff. Okay? So if you'll get out your periodic table outlines and your periodic table, we'll talk real quickly about what we've gone over. Yeah.